Hello everybody and welcome back. So, I've uploaded this video a couple of weeks back. It's a little snippet of my game that I was working on based on a concept I came up with a few years back. And a user inquired me about the method I used to animate this orb. Now, I could do just a video on how to do this step by step, or I could actually explain the principle that this particular animation is based on so that everybody benefits from it, not just the person asking about this particular orb animation. So this can be achieved via either code or physically animating the orb in an animation piece of animating software. I will showcase both methods. And the principle behind this is very simple. It's very rudimentary. It's called motion design. It's a study of how things move. Now, animation and it's in itself, be it regular, primitive shape animation or actual character animation, is based on real life. Everything is based on real life characters, real life references, albeit with animation, it's probably more exaggerated to have a more animated look. But everything is based on real life, including motion. In real life, everything is moving. It's never moving at a constant rate. It's slowing down, speeding up, and that dynamic motion is what gives things their life. And when you understand, when you incorporate it, you get a very unique feel of fluidity in your game, considering this is a game development resource. So there's an animator on Twitter by the name of George Estrada. I think he is a tutor on one of the online animating tutoring courses. He did the study on motion. As you can see, this is his portfolio. So with that being said, he made a little cheat sheet on Twitter which pretty much covers the majority of the basics in making your animation look more fluid. I'm gonna post all the links down in the description below this video so you can actually check it out and save it and use it as a reference. But when you're animating stuff in a classical manner, when you're doing classic animation with a pen, pencil, and the light box, this has to be more or less intuitive to you. But since since the user was inquiring about a very simple shape, an orb, we can concentrate on the single use of animation curves, as you can see depicted in the second illustration here. So many, if not all, pieces of professional animating software will give you access to animation curves. They essentially allow you to edit the speed of your animation. So as you can see over here, the curves depict the speed of animation over time. So the time is constant, but the rate of animation is what we vary in order to give the motion a more dynamic look. So I'm going to move on to Flash. As I said, these features should be available in majority of animating software that use automated animation, so to speak, with keyframes instead of classical animation where you have to draw on every single keyframe. So what I'm going to do is I'm going to drop this this ball here, and I'm going to display the use of animation curves before I'm going to dive into the actual wiggle effect. So here we have a ball. We're going to place a frame over here at frame 25 and one more at frame 50. I'm going to select all of these frames, move this sucker over here. So now we have a linear animation. As you can see, it reaches the end and it turns back. In fact, I'm going to turn on the loop playback. So as you can see, it's very linear, it's very straightforward, so to speak. Now, if I'm going to select both of these frames, the beginning frame and the end frame, and I can select the animation curve and add a nice little curve here, or nice slope, so to speak. When you look at these curves, the bottom, the x-axis, so to speak, the bottom axis represents time. So this is constant. But the vertical axis represents the speed, the animation speed. So as you can see, we have from 10% to 100%. And this is the rate of the animation from the beginning frame to the end frame. So if you follow the curve logically, the animation will slowly start progressing up until about frame 7, and then it will rapidly increase, and then it's slowed down by the end of the B frame, by the end frame. So if we take a look at this now, as you can see, now the animation is much smoother than a linear counterpart. Very simple stuff. Makes all the difference in the quality of your animation. Now, as I said, this is automated animation. So this is generated by the software, since I didn't have to place every single frame and move the ball physically along the way. However, when you're doing classical animation, like pixel art animation, you will basically incorporate the same curves in your mind. You will have to draw you'll have to draw your characters, your animation, punching animation, jumping animation, whatever it is. You're gonna have to instinctively use animation curves while you draw this stuff. So now let's move on to the actual wiggle effect. I'm gonna go ahead and drop another circle here, and I'm gonna go ahead and place some keyframes over here. So I'm gonna place one at keyframe 10, 20, 30, 40, and 50. I'm gonna go ahead and select all of these and turn them into a classical keyframed animation or automated animation. So now, to make the wiggle effect, we need to stretch and compress this ball along the both axes. Now, obviously, if you just stretch like this, logically, when you look at it, imagine that this is a water balloon, and over here you have 1 liter of water inside of the water balloon. If you stretch the balloon like this will represent 1.5 liters of water. Obviously, in real life, you don't gain water from just stretching the balloon, so you will have to stretch the vertical axis down in order to compensate for the volume. The volume stays constant. It's the shape that changes. So what you can do is you can go into your actual stretch functions, and in Flash we use percents in order to stretch our shapes and our objects. So what we're going to do is we're going to stretch the x-axis by 20%. So from 100, we're going to place 120. And it's always a good idea to detect the constraint effect so that this does not scale in a proportional manner, as you can see, so that we could scale them individually. With that being said, I'm going to set this to 120, and I'm going to scale the y-axis down by 20%. So this is going to be 80. So 120, 80. Move to the next frame. Let's reverse this. We're going to put 80 and then 120. So as you can see, now we're getting our little wobble there. The third frame, let's go ahead and decrease the amount of wobble. So we're going to go 110 instead of 120, and then the second one's going to go 90. Next one will reverse that, 90, 110. And then we're going to go ahead and take maybe like 103 and 97. And the last one's going to be our 100 by 100. So now, if we play this back, we technically have our little wobble. But obviously, we're not going to stop there. We're going to use our animation curve in order to improve the dynamic feel, the motion design of this animation. As you can see, now all the movements are blending nicely into each other, so to speak. This has more liquid feel to it, you know. You can play around with this stuff. As I said, these animation curves are present in After Effects. They're present in Flash. You know, useful stuff, extremely useful stuff. what I've seen over the time is a lot of like starter developers, when you see that they have some very basic games, you try to point out, like I have in the past pointed out, try to add some dynamics to your animation. And not most of the time, but quite a lot of times, I would get the same response. The developers would say, or I should say just the developer, because it's a one-man production team. The developer would say, oh, this is the style of the game. When, clearly, if it's a style, you would know that it's a style. Saying that, something is stylized is definitely not, it's not an excuse to, not put extra work into the quality of your animation. Like, you know what, I'd say if you played, or if you watched somebody play Five Nights at Freddy's 3, when you would enter these not secret rooms, but you'd enter these 2D games, like mini games. The motion in there is very pixelated, and it's very steppity, so to speak. The object moves a certain amount of pixels as its motion design. That is stylized design, But having things move in a very linear way, and not putting the extra time and effort into making things look more fluid and dynamic is definitely just it shows on your work. It shows the lack of concern for detail, so to speak. It's your own product. You will kind of want to put some work into it. So finally, we can actually go into GameMaker, and I'm going to demonstrate this same effect in GameMaker via code, because the principle behind it is exactly the same. Here we go. I'm pressing my left mouse button. We get that nice little wobble. Now, and once again, going back to the quality of animation, this right here deals with the code that speeds things up and slows things down. It gives it a much more fluid look, and it looks better than doing this. Just rigidly stopping and moving your object a fixed amount of frames. This looks better than this. Anyways, let's go back to our object. Open up this little sucker right here. So what we're gonna do in GameMaker is we're gonna create a sine wave. Now, I call it a sine wave. We're gonna generate a sine wave because my background comes heavily from music. I started with music, so when I say sine wave, I can actually hear a sine wave in my head. A sine wave is essentially a program that generates a number on a a sine wave number. I can't really explain it. This picture probably showcases the effect in much more detailed way than I could have ever explained it. So a sine wave, you provide it with an amplitude. So in this case, in this image, the amplitude is 1, so it goes to +1 and -1, and then you provide it with a rate, which is how fast the sine wave is created. This should be a function available in any programming language. So all you have to do is create a bunch of variables here. I've actually pulled this from a tutorial, a link to which I will provide in the description. It's right over here. The code is very simple. So all you have to do is provide your rate, your amplitude, if you're doing some basic numbers. And all I have here is a function for generating your sine wave. And all I'm doing over here is I'm adjusting the X scale and Y scale of the sprite. I'm setting it to 1, so it's going to be actually the actual size of the sprite. You can set this to whatever you're using. And then we're adding and subtracting the value of the sine wave. So looking back at the graph, right now, let's say when the sine wave reaches the very top, it returns a 1. So that means over here, we're going to say x scale equals 1 minus, and this will return a 1. Obviously, we don't want to have, if you do 1 minus 1, you're going to have a 0, which means you're going to have the x scale of 0. So that's why when working here, when I press the left mouse button, we set the amplitude to 0.4, not 1. So this will just decrease the x scale by 0.4. And the same thing we do with the y scale, except we do the reverse to the y value. Just like we did with this one, when we stretch the x scale, we compress the y scale. So we have to do the same thing with this stuff. So we compress the x scale and we stretch the y scale. Now, obviously, when the sine wave reaches the bottommost point, it will return a -1 or a negative value, which means that negative plus negative with a negative will become a positive, and positive with a negative will become a negative, which means that we have effectively reversed the shape. So all it is that we have here is the left mouse button clicks and sets the value of the amplitude and the rate of the sine wave, and all we have then is just a little piece of code that decreases the effect impact on our shape. As you can see, there's really not a lot of code here, but I did want to cover, you know, more than just giving you this. I did want to cover the concept of dynamic animation. This was a really good excuse to do that. Thank you, user. Here, I'm gonna go ahead and include your name in this. What's your name? Your name is Imperial Games. All right, there you go. You can now use your knowledge to improve the quality of your animations. All right, so thank you guys so much for watching. Check out Retroactive Gamers on YouTube. This is my and my friends and I gaming channel, so to speak. And check out RTAG Rise, which is the game that we're working on. It's on Steam Greenlight. We've been greenlit, so you know, no need for voting. You can just check it out. We'll post the link down in the description. If you like this tutorial, there's a donation method down in the description. It's an album of soundtracks that I've written for a game a little bit ago. Well, a couple of years ago. And I'll see you guys in the next video.